Welcome to Latinos Who Tech. My name is Hugo Castellanos. I'm an engineer and I work in Silicon Valley. This episode of Latinos Who Tech is brought to you by Audible. Audible is the world's premium platform for audiobooks with over 150,000 titles. If you're like me, you're passionate about learning new things, but finding the time to read may be difficult. Audiobooks are a great alternative. You can get a free 30-day trial plus a free audiobook by going to audibletrial.com/Latinos. Go and support them since they support us. Thank you. Hello folks, welcome to Latinos Who Tech. We're going to have a conversation with my favorite Cuban engineer, Emily Vargas.
Hello.
Emily.
Hi. Sorry, I am technologically inept.
No worries. It's not like you're a PhD student or anything, right?
No, I mean, granted, I've had the same computer for more than 5 years, and I still don't know how to use it half the time.
No worries, but I'm sure that your manufacturing skills are top notch. And
sure, let's go with that.
Let's go with that. Yeah, no, because I have this idea of you. I see you as the Latina Neil deGrasse Tyson. So you can teach us everything about ceramics and manufacturing and all that.
I don't know about everything, but I'll do my do my best to go into the unknown area.
More than I know. Sí. So I'm gonna just pin a post so people know who you are. Emilian Vargas.
Cubana está aquí.
Cubana. ¿Qué hola, Cere? ¿Qué hola?
Dale, ya tú sabes.
Yeah.
Cuando estamos en Cuba, nos hacemos esto como así.
We should just like freak people out. Let's just do it in Spanish, but like really Cuban Spanish.
Tenemos que hablar bien rápido para que tú sepas, chicas. Cuando estamos en Cuba, nos hacemos esto como así, vamos a jugar dominó.
Entonces cuando agarras el latte, tú lo agarras. Sí.
Yeah, and then at some point it's just going to start sounding like a Dominican accent. Like, oye, ¿qué lo que?
Yeah, like they all blend together, right? Like something with the Caribbean.
Yeah, except if I'm not mistaken, los puertorriqueños, they instead of the R's, they use L's, and the Cubans just remove the S's and the T's.
And Dominicans is like all of the above.
but they do have some good mofongo, you know. So
they do.
It does help. What they lack in letters, they make up in their mofongo.
Definitely. Yeah. So what's your current title? What do you call yourself? Is it like materials PhD student? Like what do you use?
So essentially, because I'm not there are different universities operate differently. For instance, there's this exam that you typically take in your first year that basically determines whether or not you can stay in the program. No pressure, right?
No pressure at all.
So some universities call you a PhD candidate immediately afterwards. At the University of Southern California, USC, they call you a candidate after you've passed your qualifying exam, which is it basically is during your halfway point in your PhD and basically says you're in the right direction and aren't just wasting your time.
Gotcha.
The past 2-3 years, however long you're in the program then.
Got it. So would you say PhD student in material science or
material science and engineering? I'm graduating with my master's in spring with material science. I was honestly iffy about whether I wanted to do materials engineering and material science, but I figured I'll kill two birds with one stone since the material science requirements are the core courses that they use for the PhD. So all I had to do is a couple more electives and woo, I'm a master.
That's awesome.
Yeah.
And then we can call you Master Vargas.
Yeah, Master Vargas and hopefully Doctora Vargas in less than 3 years. It's crossing my fingers.
It's in the pipeline. It's coming.
Yeah, hopefully.
That's awesome.
So, yeah. Cross that bridge when I get there.
So, how are you? How are things?
Things are, I'm living the dream, right? Whether the dream is a nightmare or not, that's a different story. I'm just kidding. It's honestly been really good. I'm fortunate enough to have a really good support system out here in LA. And honestly, those people have been really helping me out in the respect of those difficult obstacles and reaching those bumps in the, those walls and stuff like that. So overall, I've been really enjoying the process. It's been a lot of removing the Band-Aid kind of stuff. And especially last year, there was a lot of things that, going in from changing majors and whatnot, that was just, I think in my first podcast with you, I said, I knew it's going to be difficult. Oh my gosh, it was, it was something else.
And that's the thing. And that's why I was so looking forward to chatting with you, because I caught you like the week you moved to LA.
Yeah.
Something like that. So
right before I went to NILA too.
right before NILA. So like, again, no pressure at all.
Right.
It's not like your schedule is full or anything.
Oh, no. It's sad enough that I have to basically schedule my friends in where we could chat every now and then. It's so sad. I'm just like, I'm sorry. I'm so busy.
So I'm actually, since we're getting personal, I'm actually thinking of starting a shared calendar with my girlfriend. Just so we can schedule things like a date night or trips or stuff like that. So yeah, we're at that level.
Wow, that's insane. I hope at some point. Well, my best friends and I from high school, because one is in med school. She and I are basically like, okay, we have a 30-minute block here that we could talk on the phone. Other than that, it's like, well, it's nice knowing you. We'll talk maybe sometime in the near future, but we'll have to schedule at least a year in advance.
Oh my gosh. Yeah, and then some people, when you get to that Neil deGrasse Tyson level of fame, and you're doing book tours and all your things,
right?
You're gonna tell me, yeah, have your people talk to my people, and we'll schedule.
I hope not. I want to remain personable and, be able to give my phone number, not some fake number, and, have people like a overall pipeline of people you have to get through before you actually get anything to me. And by that point, it's almost, there's probably some telephone being played where the message is somehow warped, and then it ends up being like, yeah, this creepy person wanted to like get your phone number and information to send you something. It sounded kind of a little wonky. We're gonna avoid responding and basically ghost them.
Exactly. Like you can. I can give you access to my calendar. Just put in the last 4 digits of pi, and it'll go right in. So. Qué loco, muchacha.
Oh my gosh.
Pero no, I remember when we spoke. We did it was the first podcast episode we did in English. And actually, I was still going through this phase of because I want to make Conexiones podcast, but should I make it in English? Should I make it in Spanglish? Should I do like one in English, one in Spanish? And then I decided to, you know what? I'm going to have Latinos Who Tech, English only, for my second-gen folks and for anybody that's curious about our world, what we do. So a lot of the folks here in Latinos Who Tech, they haven't heard your story. So I was wondering if you could tell me, you share with us, your story, how you got to Southern California. How does the girl from Miami get to LA? That'd be awesome.
Sure. So like the beginning of time, or
after the Big Bang, if you will.
Okay. Yeah, long ago when the dinosaurs got hit by a meteor. There was this funny thing that I saw that we really don't know if dinosaurs had hair or not, because the hair would have been burnt out. I said, it would be funny to see.
Feathers for the feathers. We don't know.
Exactly. So imagine seeing a dinosaur with just really long hippie hair. That would be pretty cool, I think.
That'd be amazing. Like I see like a dinosaur with like a mullet or something like that. Like
business in the front, party in the back.
Yeah, till the meteor hits.
Yeah. No more fiestecita.
Se acabó la fiestecita.
Yeah. But yeah, so I guess I could start off with born and raised in northern Cuba, also known as Miami. And my parents are originally from Cuba. And they immigrated sometime in the 60s, right when the Castro regime came to power. And they immigrated actually through the Freedom Tower in Miami, which is essentially the Ellis Island of the South. And so they came through Miami, and then my dad moved to the Bronx, New York in the 70s. So you could already imagine how that was. I think some people have probably heard of the movie Fort Apache. Yeah, so he went through that. Every now and then he's like, I've seen things. But it's funny. He's like a burnt marshmallow. He has a tough exterior, but he's really sweet on the inside. My mom grew up in Elizabeth, New Jersey. I know there's some Jersey folks probably on, and New York folks on this live video.
Yeah.
And so they met in New York, and then they conceived me sometime 12 years later after getting married. And so I grew up in Miami. I always had an interest in inventando things, and particularly my dad is a carpenter, remodels homes by trade. He's just basically can do everything from remodeling homes to fixing cars. I think the time you were there, he was changing the oil or something in my car.
Yes. And we were recording, and he was out there doing his thing. And then typical Papa Latino. It's like, kids, finish your thing, and then I'll give I'll give your friend a ride back to his place.
Yeah.
And he's like, no, says, Señor, you can call an Uber. Don't worry. No, I'll give you a ride. Like, Papa Latino. Like, they gotta be in control.
Don't say no. So you met my dad. You know how
I know he's an amazing guy.
He looks tough, so you don't want to say no to him.
We went out for brunch. Remember with Monique and That was fun.
Oh, that place was so good. I went actually when my parents, when my dad came in April for a little bit. We actually went all the way out there. It's on Route 66. And we went out. He's like, we got to go back to that place. It was so good. And it was awesome going back there. But it was my parents actually came in July, and needless to say, I was helping my dad change the rotors in my car, put in ceramic carbon fiber brakes, which I'll talk about later, and among other things. So having that exposure from doing from maintenance to basically making things that you don't have accessible to yourself. I really got that exposure from both my parents. Particularly, I was the tomboy growing up. I would wear camouflage cargo pants and would always be working with my dad in the garage. Needless to say, I became very good at holding a flashlight, but for other things, he did teach me quite a few things, such as soldering to using power tools and things like that, which was really nice to have that exposure. And whenever I wanted a toy or something like that, we didn't have a lot of money growing up, and so me dio pena always to be like, Mom, Dad, I want the thing in the magazine that I got in the mail. So I'd be like, how can I make this? And so I would just think about it for a little bit, and before I know it, I'm grabbing things from closets or from the recycle, cutting things, and just would be the little Toñita in the esquinita just working on something. And my parents would always be like, Toñita, what are you up to? I'm like, nothing. And before you know it, they see me with all these things. They're like, when did you get that? I was like, I made it.
Right. Like, and I love that adaptability, the whole inventando thing that, we'll figure it out. I love that as part of that immigrant mentality we have, right? Right. I don't need to have the latest and fanciest MacBook Pro to get my homework done or whatever. I have my 5-year-old computer and it works just fine.
Right.
So I love that. That. So can you remind us why? I mean, because you went to Florida State, you got your degree in industrial engineering. Go Knowles, always, the chomp and
war chop. Yep,
war chop. And that's for the people in the live, because the people in the podcast are gonna be wondering, what the hell are these guys talking about? We're doing the chomp. But yeah, and then so you got your degree and you got this plethora of internships under your belt.
That was interesting. I one day I asked myself, I'm like, wait, how many times did I move over the course of 4 years, and how many different experiences did I have? And it was absolutely amazing. I mean, I got a majority of these experiences, if not all of them, Society of Hispanic Professional Engineership, which I got that exposure at University in Tallahassee. Florida. And so I was really grateful for that and getting that exposure from beyond where I grew up in Miami. Basically seeing the United States. I had never gone out and lived somewhere else. So having that opportunity was just really eye-opening that, wow, there's so many different things out there. I experienced snow for the first time, and that was something else. I'm like, what are these white particles falling from the sky?
Yeah, we don't have that in Cuba, especially not North Cuba.
Yeah, exactly. I mean, what is it? You see people wearing ski gear when it turns 65. They're like, oh, snowstorm, ooh, and it literally is like a palm tree falls, or like one of the leaves falls, like, too much wind.
So, when did you know you wanted to? I guess it's two questions, but we can combine them. When do you know you wanted to get your PhD?
Okay.
And when do you know USC is my school? That's where I want to go.
Okay. Yeah, so going back to how I grew up, since I had that exposure with working with my dad and stuff, I always go with him to Home Depot. And naturally, while he was talking to one of the employees, I would always be in the showcase areas, just checking out all the different things. I'm like, why is this like this? And I'd be like, Papi, this is not real madera. Like, what the heck is this stuff? And he explained to me what particle board was. And that was, I think, the first time I got an exposure to composite materials. Because particle board, as most people know, is, it's not real wood. It's basically compressed sawdust with resin to make it look, to have the capabilities of wood, but, it's a lot less expensive. It's lightweight. And, IKEA furniture is one of the largest areas where you see particle board, and that hopefully the stuff lasts 5 years or before you have a move, because once you have the move, the stuff is probably gone.
Right.
So having that exposure, and then as I had always been making things and stuff in high school, I was involved in the entrepreneurship academy at my it was a strand there. And then I actually made my own little business, like from making something that I thought was pretty cool. Nice. But I first thought I wanted to go into law, and then I wanted to go into business of some sort, accounting. But I realized I'll talk about with my degree at FSU, I liked it, but I didn't love it. And so the moving forward to college, I didn't know what engineering was. I think I one day Googled right before, while applying to colleges at high school, I looked up, okay, what's like inventando mixed with math? Because I really loved math. I was a mathlete in high school. I'd compete in math competitions in the summer for fun. So I was like, woo.
Of course you were a mathlete, of course.
Yeah. It was what I enjoyed. We should have gotten like Letterman jackets too. That's how intense we were. Wow. So I had that exposure there, and I looked up one day, those two words, inventing and math and engineering came up. So I said, I might as well look into this. And I saw that it was very intensive in terms of the program and stuff like that, like the overall coursework and whatnot. And I said, I want to do this. I don't want to do anything medical related because I don't want to deal with blood or potentially killing somebody. So this is something where I know I could be able to challenge myself. And of course, at Florida State, industrial engineering, for those who don't know, is basically a combination of looking at the quality control processes, improvements in the relation to Six Sigma, so finding ways to make things better. So you interact with all the other engineers, engineering disciplines, but you take what they're working on, whether it be a product or a service, and make it better, whether it be faster, stronger, quicker, and things like that. So I realized, again, I liked it. And through my internship experiences, I tried different areas of industrial engineering, which was kind of nice having that exposure before graduating, because I said, nope, don't want to do sales engineering. Nope, don't want to do quality control. Nope, don't want to do this or that. But then sometime in my mid-sophomore, junior, once I finished my sophomore year and going to my junior year, I had an identity crisis. I was like, what? I don't like industrial engineering. What am I supposed to do now? I'm already in my third year. I'm not going to switch majors. While that I absolutely, whenever I talked about my experiences in industrial engineering, it was very, just pretty monotone. But it didn't occur to me. I had been doing research for about 2 years at the time at the High Performance Materials Institute in Tallahassee, where I was working on the manufacturing processes of materials. And I know we talked about carbon nanotubes and Bucky paper in our last
Bucky paper
podcast. So so I won't talk too much about that, other than it's a very thin material that can be used in lightweighting applications, and it's very, very strong and has all these other properties. And so I worked with making that stuff, and one day somebody pointed out to me, when you talk about your research, it's like your eyes spark, and you should look into getting an opportunity with something, and try it out and see if you like it. So fortunately, in a couple of my internships, I was able to get that exposure, and I realized, wow, I really wanted to get into this. But the question was, will I be able to get that exposure and understanding of materials and how they work through industry, or will advanced degrees be a better option to start before going into whether it be an industry or other related workforce opportunities? Not to mention, I was always very curious. Curiosity killed the cat a lot when I was younger. And there was this area of wanting to understand the unknown, because there's a lot of things that aren't on Google that are still being discovered to this day. You see all of these Nobel laureates coming up with all these new ideas and theories. The gravitational waves being an example of one of the most recent discoveries, or rather the imaging. And so all of these unknown areas really fascinated me, and I wanted to be a part of that. And in industry, you do have pros and cons to just, in general, you have advantages, disadvantages in industry versus academia versus other routes. With academia, you have a little bit of more of a breadth and capability of doing whatever you want. Of course, it has to align where you got the funding and what the project proposals were and whatnot. But you do have some limitations in industry where it has to be some form of value proposition to the company in relation to a program or service. So seeing that as an opportunity to basically be all, I could do whatever I want. So anything that I haven't had exposure with, or something that I did have exposure with, I could expand on that. I don't really have any limitations there.
Right. So you don't have a business unit that you have to, check in with them and, okay, what are the products that this is going to go into, and basically justify your existence as a researcher every 6 months.
Exactly.
Like granted, there's things like grant writing that you're asking for money as an academic, as a researcher, but you don't have to apply for the grant. Right, you get some things from the school already, and
right.
Yeah, so that's awesome. I'm happy you found your niche in research. I'm happy you found it.
Yeah, and there's advantages again in industry. There are grants that you could apply to for instance, the National Science Foundation. You could apply for grants that in collaboration with an institution, but you still, regardless in both areas, you do have to have a pitch of some sort of like, why are you going to deviate this way? And be able to prove it, whether to the executives approving the budget or to the NSF program officers that are saying whether or not you could move forward with this project. So there's a lot of pros and cons. You can find a lot of it on the internet or talking to other individuals in academia, professors, faculty members, and stuff like that. So I saw that opportunity there, and then not to mention, I just didn't understand how materials worked. I understood things like, oh yeah, if you pull it, you could see the strength of it, or you could test for conductivity, but I didn't understand why materials had certain properties that they do. And I mean, so then there was the question of, why do the PhD over just a master's? And I think that some masters can be just course related, and others can be both course and having a mini thesis. But I find that with the limitations of 2-3 years, how much in depth can you really get into an area of interest, for instance, in an area of the unknown? PhDs are average 4.5, 5 years. Hopefully I'm not here longer than that. I know some people that it just depends on the research you're doing and if the stars align. But
Right.
yeah, in general, that's why I wanted to do PhD, and particularly materials. That exposure from growing up, and then at FSU, having that overall gap of knowledge that I wanted to fill. And you asked me why I chose USC in
Yeah,
particular.
yeah. Well, why USC? I mean, besides
Mm-hmm.
the perfect weather and all the
Well,
fun stuff.
it's like Seattle weather today. It's been raining and cold, which I kind of like because I really like Seattle. But the sun is very nice. I applied to graduate schools twice in different years. So I applied in the 2016 year to matriculate in fall 2017, and then I also applied in fall 2018. In 2017, I decided to take a gap year because I was really burnt out from undergrad, and not to mention the identity crisis that I was talking about. I didn't have enough exposure with materials-based applications and knowledge. And so I felt that I really needed to get that exposure to confirm that I want to spend 5 years
Right.
doing something like this. And not to mention, I got into schools, which I was absolutely fortunate enough to be able to do, because I was so scared. I'm like an industrial engineer applying to mechanical engineering and material science engineering programs without that previous background. It was massive imposter syndrome, massive, like, how am I going to convince these people to, when I've never taken a real thermodynamics class?
Yeah, like imposter syndrome. What's that? We don't talk about that in this
Yeah,
podcast. What's
what?
that?
Huh?
Like, you're an engineer, figure it out.
Yeah,
Oh my God.
exactly. And so that was, I decided to take a year off, get my mind clear a bit. And so I worked in materials-based roles, and that just reaffirmed my decision to want to go into academia versus industry route. And so the second time I applied to a less amount of schools. First time I applied to, I think, 9. This time I applied to 4. And I chose the universities I applied to based off of the research and the connections I've made with advisors. Most of the all of the universities, actually, I had a connection at my previous internship, Boeing, whom connected me in the summer, and I had a discussion with them, which was really nice. So I got that a feel of whether or not it's going to be a right fit for me if I were to join their lab. And so reason why I chose USC, location was really important. I wanted to be happy. And there's another component. I wanted an international airport nearby because flights are just expensive nowadays, especially during holidays and whatnot. So I wanted that there. I also wanted to be able to have, opportunities to go outside of where the university is and explore different opportunities, adventures, and go out of my comfort zone in things I've never tried before. And so the locations I chose for those graduate schools had all of this and then some. And so what ultimately led me to USC was my lab. I work at the MC Gill Composites Center at the University of Southern California, and my advisor is named Dr. Steve Nutt, and you heard that right, N-U-T-T, Nutt. I'm in the Nut Lab, we're a bunch of nuts, and I absolutely love him. He is just out of this world. His personality alone won me over the first time I talked to him on the phone. He even called me multiple times before my application was submitted to ask me, do you need help with anything on the application and stuff like that. I just thought that was
that's amazing.
insane.
Like, he really wants you in the team, right? And he wants to, he sees the talent on you, and he probably sees a little bit of himself in you, the way that he was as a PhD student. So that's awesome, because like that PhD advisor and that PhD student relationship is so important, because they're your boss, your mentor,
your advocate,
your sponsor, your friend to some extent. So it's very important. It's,
absolutely.
I'm happy you found the fit.
Yeah, he's been great. A lot of people. So it depends on the university. I entered USC already knowing I wanted to work with him. Some universities do a speed dating kind of thing where you switch labs every 3 months or so for the first year, and then you make a decision based off that. And sometimes it's a good fit with your advisor if you pick them. I've known people that have switched advisors halfway into their PhD because it wasn't a good fit. There is a risk. especially if your university you're only interested in one faculty member there. So then there's the question of, do I switch universities, or do I find someone and kind of force myself to want to work with them? There are different things that happen in a PhD program that nobody really talks about.
I had a professor at back home in Florida. That's funny because I'm in Latinos Who Tech. So like I'm in my more like gringo side of things. So like home is Florida in a way. I mean, I lived there for 20 years, right? So
exactly.
It's like for some people like us, like asking, hey, where are you from? That can be a bit of a loaded question sometimes, like where my parents are from, where I was born, where I grew up, which passports do I have?
Like, or what's your background?
What's your background? Yeah, that's the innocent one. What's your background?
Yeah.
But I had a professor back home that he actually he didn't have he was ABD. He was Audible dissertation, and I noticed that, hey, like he actually had it in his resume. So I was wondering, like, hey, why did you never like finish your PhD? And his advisor actually died while he was going through his PhD program. So yeah, those things happen, right?
Absolutely, so, life happens.
Yeah.
And there's ways. Sometimes there is an option to navigate around it despite it happening, but then there's others where it's just a roadblock. And so how do you get through that? Do you take the situation and try to find a solution, or do you accept it at face value, kind of move forward? And it sounds like in that case you kind of just accepted it and move forward.
Yeah. He got a job as an instructor at the local community college, and that was his career path. He loved the teaching aspect more than the research aspect. So he's still teaching at Valencia in Orlando. So,
yeah, I know about Valencia. So I forgot what we were talking about.
So you got to your PhD, you did the program, you're in. So how long have you been in your PhD?
This is now I'm finishing. Wow. Oh my gosh. It's year 2. I'm finishing my first semester in year 2. Gotcha.
So what do you wish you had known back in
last year when I talked to you for the first time?
Yes. So like a first month of year 1, what do you wish you had known?
Gosh, so many things. One, I mean, it's kind of, I think, known but also unknown. You're not alone. There are people that look like you. Maybe you just have to kind of find them a little, or rather put a larger research to find them. But there are people that exist similar to you, Hispanic, first generation, that are in STEM-related fields. It's hard to find them, but once you do, you find that there's more of them, and then you kind of just congregate them all together and make like a giant circle where you just rant about, advisors to a little bit of everything. So I wish I would have started that earlier my first semester. It wasn't until my second semester, I think I started reaching out more for help and trying to find these people. And some of them even found me, which was kind of interesting because it was at different events and stuff like that where they're all, hey, wait, you're that too? Wait, no way, and found that connection. So I wish I would have done that earlier. I was very alone when I first moved to LA because I didn't know anybody other than, the Ship Familia, but they're all over LA versus not at USC. And so then trying to build that overall community was tough. And so I wish I would have tried a little more to go to different events and stuff like that. I was just so overwhelmed with my coursework. I said, I don't have time to go to this diversity event for the dinner, whatever, stuff like that. I need to focus on getting through my classes. It was a big knowledge gap for me from industrial engineering to material science. So, and then there is an option of taking undergraduate courses as a graduate student before taking the graduate courses. But I didn't want to do that because I said, it's going to take more time. So I said, you know what, let me go in and just hope for the best. Just pray to all the gods, pray to
the Shango, Watala, do the Santeria thing as well.
Light up my little velita.
Oh my gosh, would that be like offensive to people? Like if you're in your at the nut laugh, and you have your little like Oatala altar like right next to them. Le deja perfume, le deja ron. Like
I don't know, to be
I'm
honest.
kidding. I'm kidding, right? But like
I don't think anybody would care, honestly. Half the time,
like Santero PhD.
yeah. I don't practice Santeria.
Like I do. Oatala.
Yeah, I've told people
Chango.
multiple times about in Miami on four-way intersections, you see brown paper bags with feathers everywhere. And I'm like, yeah, that's chicken that the Santeros sacrificed during their rituals and stuff. And they say, what? And I said, yeah, that's pretty normal. And where Santerias originated from Cuba. And so it was so common. I didn't think of it as being something not really known and weird. It's the same thing with the side besito, or saying like dale and stuff like that. That's not a thing in other places. Or speaking Spanglish.
No, definitely, and I think that's why it's a bit of a double culture shock,
Right.
because like growing up in South Florida, that we're used to. Okay, we're part of this Hispanic, Latino, Latina, or Latinx, whatever you want to call it, community.
Right.
And then we go into, oh yeah, I got an internship at Boeing or Intel or Microsoft.
Right.
And then you go to the West Coast or the middle of the country, and it's like, wait, where are the Latinos at?
It's like, I can't find them.
Yeah, that was my experience. I moved to Portland to work for these guys for Intel for like for 9 months as a co-op, and I remember that I think I didn't speak Spanish for the first 3 weeks with anybody.
Wow.
Because I just didn't find anybody.
Yeah. No, that's crazy.
So it's a double culture shock, because you have the culture shock at the office, and then you also have that community culture shock. It's like the thing I miss about Florida, man, is just the sheer amount of like Latino bakeries around.
Oh
Like,
my gosh,
you can get like your cafecito, you can get your croqueta, you can get like your, and it's not only the food or the coffees, it's the community aspect, that the sense that it's like it's missing, so it's but I hear you.
No, it's that. Yeah, so then trying to find that community was tough. So I wish I would have done that more. Also, a big thing, I find it so commendable for people that are working in industry and also doing part-time schooling, because I just took 1 year off and I forgot how to be a student. I absolutely forgot how to study. I forgot everything. And so going into school, I was all, I made it through undergrad. I would know how to study and stuff like that. I failed my first exam in grad school. It was just a complete eye opener. I said, wow, I really don't know how to study anymore. Or rather, the things evolve, and the type of learning methods that you use in previous years may not be the same way that can be applied, that work for you. And so that was, I think the biggest piece of advice is before starting graduate school to make sure you try out different ways and methods that work for you in terms of studying, retaining information, learning before you enter the program. So I think that was a big obstacle for me, trying to figure that out. I tried everything. I tried from reading the books, annotating them, to watching videos on YouTube, to trying to find making index cards and everything, and it was really hard for me to figure out what worked best.
So what system do you build? What worked for you in the end?
What worked for me was mostly trying to find somebody that already knew what the stuff. And particularly, I have a couple really good friends that know how to bring it down to layman terms, because a lot of faculty members, they'll say things like, oh, obviously it's this, you should have learned it in undergrad. And here I'm all like just twiddling my thumbs. Yeah, I didn't learn that. So I reached out to a lot of upperclassmen, and that's the biggest thing I did learn my first year, that to reach out to people who've already endured it. They know better than anybody else how to get out alive from these courses, because they've had the same experiences. And so getting them to explain it in different ways, how they understood it, definitely helped me out. And then also what I used to do a lot that I forgot sometime in undergrad and revisited was trying to find a way to remember things in a silly form of fashion.
Oh, like mnemonics or
Yeah. So for
making
instance,
songs about them or
yeah. So I remember for instance, while learning the bones in 7th grade or something, I would make a song like you drive your car with your carpals, you step on tar with your tarsals, you shake to Elvis with your pelvis. So doing things like that definitely helped me out to remember things and I would even find ways with mnemonics to try to somehow input what the thing I'm trying to learn is in the mnemonic. So I'll make songs with talking about what the actual application or what definition of the word is. So that definitely helped out a lot. I think a lot of people don't realize that, as I mentioned before, life happens during your graduate degree and just in general. So there are services on campuses that you may not be aware of. For instance, legal services. If you're having any situations with for instance, if you're international, you have any visa issues, to any landlord property situations, or everything. There are free consultation services at a lot of universities. Another thing is mental health services. Most people don't realize that a lot of these are complimentary to students, especially if you're provided insurance with your program. There's a really big area that you could tap into. And they have counseling groups, and they actually have separate organizations specifically for graduate students, because how you experience school as an undergrad versus a graduate student is vastly different. You feel you're not the same young self as you are in undergrad, but at the same time, you're not able to turn off your brain after the 9 to 5. You're constantly always working, constantly learning something and doing other things. And that was something that I forgot about school, that you don't turn your brain off. In industry it was a little different. I could sort of turn my brain off a little more. And so there are resources
and it
helps
helps it helps if you like build little rituals that let you know that okay, the day's done, I'm going home, that kind of thing. So
right.
So I have this. It might sound silly, but it works for me. When I take off my work badge, I'm not in Intel mode anymore. You know what I'm saying? So it's like I just like taking it off and leaving it at that bowl by my kitchen table.
Right.
It's just that okay, I'm home now. Now it's home stuff.
Right.
So it's just a way of like checking out, if you will.
Yeah.
But I'm sure like in grad school that's different, right? Because you get home, you gotta read a paper.
Yeah. My first year, I didn't do that at all. I would bring my laptop home and continue working. Every time, I think on average, I had 4 hours of sleep each day, if that. It was tough because again, that giant learning gap there was tough for me to adjust. So I had to put in more effort and time to learn something versus somebody that already had a background in it. So now in my second year, because I'm only taking one class now to get the master's, as I mentioned, I tell myself, leave my computer in the lab at my desk so I don't feel obligated to do any work when I get home. So I've been doing that. And so then I program my brain at 7 o'clock when I get home roughly. I'll make dinner and I'll just wind down a little bit, whether it be putting on my humidifier with eucalyptus oil, to turning on some candles, doing like skincare regimes, things like that, to add some component of self-care in there. But yeah, I think those were like the main things. Actually, nobody really tells you that the programs, and more specifically the department that you're in, especially for a PhD program, they are going to be your largest advocates and they want you to succeed. It may not feel it. You may have an advisor that may not want you to succeed, or may feel like they're just kind of waiting for you to fail out or things like that. But the department in general are the individuals that accepted you into the university, and it's really important to remember they're there for you. So what I mean by that is there are requirements for a specific program and a degree. You don't know what you don't know in the respect of asking if you could have a substitute for a certain course that may not be of any relevance to you. So that happened to me in particular. There was a course that I couldn't take and I didn't want to take. And so I talked to the dean, I talked to the department chair and everything, and they said, absolutely, so long as you get an approval from your advisor that this is a relevant course to your research, that's it. And I said, wow, I
Nice.
wish I would have known this earlier after enduring 6 weeks of the course and realizing, oh my gosh, I can't do this.
Yeah,
And so that,
and you don't know what you don't know, right? So
mhm,
like, and that's why, like we have these conversations, and I put together this content so we can share and people can find out,
mhm,
and also I think it's powerful that sometimes you just gotta ask.
right.
You just gotta ask,
The worst answer you'll get is a no.
yeah,
Hmm.
yeah. It's
And
like,
that's,
what has been your experience like getting accommodation for testing and things like that? Are they like open to that or?
yeah, so I had accommodations for testing in undergrad. It was a bit of a tedious process in the respect of, for instance, with a mental health related accommodations that versus, physical disability. You do have to obtain, doctor's notes and stuff like that, and
Mhm.
then kind of they'll you have to put in the request of what kind of accommodations you're looking for, whether it be extended time on exams to, reduce distraction environments, things like that. So it was roughly the same in undergrad as it was in graduate school to get those accommodations. Granted, I always have a hard time. In undergrad, I was very nervous, giving the letters of accommodation to faculty members, especially ones that knew me. And I think I talked about that in our last in the podcast I
Mhm.
did with you. And so there's a bit of that, oh, people are watching me give a letter, or rather they see me that I'm not in class when there's an exam going on. But at some point I said, I don't care what they think.
Yeah.
This is for me. This is for my success. And this is for my journey to get to where I want to be. And so it's very similar in grad school. I mean, now I'm like, okay, got to restart all over again. And not to mention the courses are smaller. So it's pretty obvious if out of 10 people, there's one person missing while taking a test. And at the end of the day, I said, you know what, this is what works for me. And if people are going to judge me based off that, then frankly, those are people that I shouldn't have in my
On your radar,
journey,
right? So.
for when I'm in my degree. So in general, it's more or less the same. I did want to make one comment though. So most people don't, in terms of the worst answer
Mhm.
being no, when you're applying to graduate schools, most people don't tell you that you get fee waivers for all the applications and up to 50% off a GRE fees. The GRE, I think, is $200 or something. There are applications for the GRE, whether it be a need-based income by income, or if you apply to fellowships or a part of the things like the McNair Scholars, the Gates Millennia. If you apply to the GEM Fellowship, they give you those waivers for not only the GRE but also for applications. So you don't have to pay those $100 per university applications. They're free. And even if you don't get it through there, just ask the university. What's the worst answer you're going to get? No, right?
No, that's the worst thing.
I had every single university I asked said yes if I didn't get it through those avenues. So that's one comment I did want to make about,
No, no, thank you for that.
asking for things that will help you in your success, whether it be through financial means, whether it be through success in academic areas too.
No, thank you for that. And I think that like as we see in academia, all these and industry as well, all these efforts of bringing more diverse workforce, more diverse student
Mm-hmm.
bodies, this diversity of
Right.
thought. Uh, Again, to the university, $100 is nothing. So I mean, the fact that they're giving you a waiver on that, that's again
Absolutely.
like for them it doesn't cost anything, and for you it was
Mm-hmm.
a 10-minute email. So it's
Right.
go for it.
And I mean, $100 to them is adding, for their statistics, oh, we had 40,000 people apply. So you're one of those 40,000 individuals. And then they could either increase their acceptance rates or decrease their success rates based off of you getting that fee waiver and applying. So
Hmm.
it benefits them, also you as well, because $100 is
Definitely.
$100. I
Yeah.
can do a lot of
No.
things with $100.
Definitely. Yeah. How many croqueticas can we get with $100?
Oh man, I mean the prices are going up for the ones at Isla Canarias in Miami, but they're still so good. They're the best ones. Just a
I
PSA for anybody that goes to Miami. Isla Canarias is a restaurant there, the best croquetas ever. I will literally argue with anybody that says otherwise.
gotcha. So let's add Islas Canarias to the show notes.
Yeah, exactly.
So it's the day before Thanksgiving, and we have this thing. And again, there's this stereotype of you're going to the Thanksgiving table and you see your relatives, tios, tias, and stuff. and they ask you like, "Mijo, what are you up to? What are you up to?" Like, "Oh, you're
Y
still
no,
in
tiene un
school." Like,
novio.
y el novio, y la novia.
Yep.
So I wanted to take this opportunity to talk about your research
Sure.
and what you're working on,
Yeah.
and again, like, feel free to get as technical as you want.
I actually have my glove ready because I'm going to
That's
show some stuff.
awesome.
Yeah.
That's
I feel
awesome.
like Michael Jackson right now.
Cool. So I'm gonna take the video and I'm gonna post it in YouTube as well, so people can
Oh,
check it
cool.
out.
Awesome.
But imagine we're at the Thanksgiving table and Mija, so what are you working on? What is this CMC stuff that you do?
So what's a PhD and stuff? I've gotten that question from professionals actually. What on earth is a PhD? And it's important to have that education. So I work on ceramic matrix composites, or CMC for short. For those who don't know what a composite is when you combine two or more materials together. Typically, one provides stiffness or strength. So you could think of your hair when you pull it in one direction. It's very strong, right? Unless you pull it really hard and it breaks. Then you have another material that acts as a matrix. So what I mean by matrix, it kind of glues everything all together, the fibers itself. So when you combine these two or more materials together, not only do they possess the properties that the materials had by themselves, but then they also have brand new properties together. As I mentioned before, particle board is a good example of a composite. The bricks for the pyramids are a good example of composites as well. They use straw and then mud. They lay the straw in different directions to provide the strength, and that's why they're still up to this day. So with ceramic matrix composites, you could think of the fibers as being, they're made out of ceramics. So I actually have I don't have with me like bare ceramic fibers, but I can kind of show it here if the lighting is decent.
Oh, nice.
Disregard the hole because that was from us hooking it on. But so this is a cured, just a one layer of weave of ceramic fibers.
Is that flexible? Can you bend it or?
Yeah, it's
really cool.
It's pretty flexible. As you add more layers, it becomes stiffer. But for instance, I'll show you as well. So these are glass fibers. And you can see that they're woven in different directions. Sometimes you could use basically thread, and they're all in the same direction, so unilateral fibers. And so that's essentially what provides the stiffness there. In terms of the reinforcement, it'll be some form of resin for regular composites. So I have an example here of a cured, this is benzoxazine resin. It's cured, and so it's very hard. And when you mix the two together, you get basically, let me grab this, you basically get a form of composite. It can't really see in the video here, but there is some reddish coloration in where the resin is. And so the biggest advantage with composites is for lightweighting applications, non-corrosive, for increasing fuel efficiency and all the sort. And so with ceramics in particular, they have ceramic fibers, and instead of a resin, there's a thing called a slurry. A slurry is basically, there's powdered ceramic nanoparticles that are embedded with some form of solvent, liquid kind of thing. So imagine you're putting your Kool-Aid powder and water together and putting it in a blender. That's basically, you're able to transport the powder into a cup because of the liquid versus it being slightly moist and then being stuck in the blender as you're trying to scrape it out. So you could think of the slurry as basically helping the particles move fluidly in order for them to get into the fibers. So
it's a vehicle to transport the. Got it.
The particles, because you want the particles to be in your ceramic because they add further strength to your material. And so you have the dry fibers, as I showed you, and then you have that slurry, that liquid. It goes through an impregnation process. I absolutely don't like the word.
Impregnation.
I don't know. Yeah,
oh my gosh.
I don't know why. I don't know. A bunch of scientists come up with these really wonky words. So you impregnate the fiber with the liquid, whether it be a resin, whether it be the slurry, and then once it's all together, you can it goes through a manufacturing process that you're basically heating it up to cure or harden the slurry. So then you have a hardened material like a composite, as you see here. So typical ways of overall curing the part include an autoclave. Let me see if I could kind of show it here. This is our autoclave.
Oh my gosh, I'm honored. You're taking us through your lab.
Yeah,
That's
I'm
really
going to
cool.
do like the MTV Cribs for my lab.
Por favor.
Yeah, it's like, welcome to MTV Cribs. So this is an example of an autoclave. Oop, okay. You could probably see, let me see if I could do this. Here, this black tube thing is used basically when you put the fibers and the resin on a thing called a tool plate. It's basically a piece of aluminum. And it's in a vacuum bag that it basically sucks out the air in order for so there's no contaminations and stuff like that while it's curing.
Right, like foreign objects and stuff.
Right. And to talk about what an autoclave is, it's basically a high pressure, high temperature cooker that will essentially cure the composite. And so there's ways of doing that. What my lab does, we specialize in out of autoclave processing. So what I mean by that is basically using non-autoclave methods to cure composites. And the reason why we don't want to use autoclaves is, as you saw, it was a pretty small area to fit a part in. Boeing, for instance, has some of the largest autoclaves because they have to fit full wings and full bodies of planes in there. So it's a big space concern. You're limited to geometry. It's very expensive to run. Boeing has to be running it 24/7 in order for them not to lose money.
Well, justify the cost. And
Yeah. So then the question was, how do we make parts of the same quality as an autoclave without using an autoclave? So that's what my lab does a lot of research in. So we use things like ovens. I could also show, I think everybody's kind of seeing an oven, but that's an example of an oven there. We have different types of ovens, whether it be, vacuum ovens and stuff like that. I'm going to go show real quick the hot press. So yeah, welcome to my crib.
Nice.
This is kind of like the day in the life, right? So this is a hot press, as you could kind of see. It looks like a panini press, basically. So this.
I was gonna say, so you showed us where you make the turkey, and now you're gonna show us where we make the pan cubano, the Cuban sandwich.
Yeah. So this comes down, and it has heat applied to the composite, and it'll basically cure it as well. And this is one of our bigger ovens here. Vanna White kind of thing here.
Nice.
And there's also other methods.
When you do the press, is it because you're doing like two-dimensional, like sheet-like composites? Okay, gotcha. So like the one you showed me was made there, right?
Right. Let me see if I could kind of show this one. So we actually, the ovens would be used typically for different shape materials. Maybe you can kind of see this giant tool thing. Oh, it's really heavy.
Yeah, careful.
Yeah, this is not a flat part. It's actually a tool to use for if you're trying to make something of this geometry. You basically lay the fibers that I talked about that have already been impregnated resin in onto that. So then it makes this is like the negative of it. It'll make the positive.
It's like a mold?
Yeah, basically a mold.
Okay.
Yeah, so you can make molds from composites for reusing multiple times, because with metals, if you make molds, they start wearing out over time. And so this is like a good application too. There's also this method called vacuum infusion. Let me go back to where I was sitting, where that could be used for multiple geometries as well. And let me see if I could grab it real quick. It's kind of hard to see, but basically, as I talked about the tool plate thing, it's just a piece of aluminum. You can see the black thing is a piece of carbon fiber. And so this bag thing here, that's the vacuum bag. And you can see it's under vacuum. This little port thing is where it pulls the vacuum. Through this, you can use, instead of it would be dry fibers that are underneath this vacuum bag. And then you use, it's called vacuum infusion. And as the name says, you use a vacuum to infuse the fibers with resin. So there would be like an inlet and an outlet port that will suck the resin into where the vacuum bag is, and then it'll impregnate the fibers via that vacuum. It's like, I think,
how do you make sure that the particles are spread out uniformly on that piece that you want to impregnate? Because
it depends on the you basically, it should, while it's going through the vacuum and the vacuum bag, it'll start dispersing. However, there are different kind of components you could add to the vacuum bagging that allow it to, spread out versus kind of going into one little area. There's this, I wish I had it out, but it's like this kind of spiral tubey thing that the resin will go through. And basically kind of like, instead of it going just flat straight like that, it'll start like opening up kind of like a squeegee. So then that helps with that. And
because I'm picturing and for the people in the audio it's essentially imagine like a Ziploc bag that you are wrapping around this component that you want to build as a composite. But I'm thinking of like the frosting on a cake, right? That sometimes when you spread it on top, like it gets uneven. So like since it's so expensive, the process, like that'd be heartbreaking, right? So you get like a layer that has more composite than the other.
Yeah, and so that's why what the method you're talking about with the frosting on the cake is actually called wet layup. You know how I said with the vacuum infusion, you're using vacuum to disperse the resin, it'll spread uniformly. With wet layup though, is as the name mentions, you have the dry fiber and then you literally pour the resin on top of the fiber and then use like a squeegee and go by hand to spread it all throughout. And that will lead to some areas having more than others, and it'll have that inconsistency. So that's why wet layup isn't really done too often in industry. They use manufacturing processes. So you could think of like 2 rollers and the fiber going through the rollers to basically spread and make sure there's a distributed even layer as the fibers go through. Like let's say there's like a little bath here. Actually, let me just draw a picture. Pictures are a lot easier.
Pictures are a lot easier.
Yeah, so okay, so let's say the fiber, this is the fiber, it's going into this bath, then it'll come out this way and then go through these foam rollers. So the bath has the slurry, the resin.
I see.
And then it'll basically go through these rollers to just squeeze out any of the excess resin to make sure it has a distributed even layer all throughout. So those are ways to kind of prevent the frosting incident. They do still wet layups in industry, but they'll have methods of making sure quality control and ensuring that they're as not as uniform as possible for the application. But yeah, so you kind of do the same thing with ceramics. There are different types of ceramics. There are non-oxide and an oxide ceramics. So oxide ceramics are basically they have oxygen in them. So you could think of like alumina or like zirconia or things like that. Non-oxide fibers are typically like carbides, nitrides, so basically don't have oxygen. So the advantages of non-oxide fibers is that they could withstand higher temperatures. But as it goes to a higher temperature, it does have a potential of forming oxidation, and you don't want oxidation on a part or a material. Oxide materials, because it has oxygen in them, they're not prone to oxidation at high temperatures. Oxide fiber composite CMCs they have longer lifetimes. So that means that they could be used multiple times in like multiple hours, let's say in an aerospace application. So like it could last like 100,000 hours before it leads to a failure and needs to be replaced versus a non-oxide. As well as the oxides, for the manufacturing process, they need lower temperatures, which lower temperatures equals less heat and less energy and less electricity that needs to be applied. So it's good for money and a cheaper perspective. And you can also make them faster than non-oxides. So in my lab, what we're working on is how the manufacturing process of the oxide ceramic composites, how the manufacturing process affects the microstructure of the material and how the microstructure affects the overall behavior of the material. So right now there's basically a 20% void content in the material. So I'm going to draw a picture and kind of give you a perspective of what 20% void content is. So let's see, you basically have a bunch of holes. Those are the voids in the composite. And you don't want holes in a material that should be really strong, right? Because think of Swiss cheese. Where the Swiss cheese fails is where the holes are, right? And then it'll just start, it'll break quickly. However,
especially if you're making wings for Boeing, you don't want it to like break.
Yeah, you don't want anything's breaking anytime soon. Ceramics are brittle, as you see with ceramic stuff that you're using in the kitchen and stuff like that. The moment you drop it on the floor, it breaks. So that's why they use the fibers. The fiber adds the stiffness. And the difference between ceramic matrix composites and like reinforced carbon fiber or glass fiber reinforced polymers is not just because of the materials being used, but also how they fail. So with glass fiber and carbon fiber composites, they fail first in the fibers and then in the resin matrix. Ceramics is the opposite. They fail first in the matrix and then in the fibers. And so you do want a percentage of void content because let's say a crack forms. Let me draw like a little crack up here. Let's say a crack forms right there. The overall void will basically stop it in its path before versus it going like all the way down here kind of thing.
Oh, got it.
Like
so it's kind of like when your car's windshield breaks, has a crack. What they ask you is like, hey, take a knife and etch it in the end. You know, make a perpendicular cut. So it will stop the break, you know, while you get it replaced and stuff. Okay.
Yeah. Awesome. Most people don't know that the glass that's used for cars is actually a composite. They embed it with resin. That's why, you know, you see normally glass when it breaks, it shatters into like giant, like jagged edges things. But when cars, the glass breaks, it makes like tiny little pebbles. And the reasons why is because there's polymer embedded in the glass. Most people don't know that. Fun fact, it's a composite. But yeah, so those are ceramic matrix composites in a nutshell. As I showed earlier, this is kind of what one. This is like a single sheet. Normally, a composite will probably have up to 12 to 18 plies or sheets of the material. And it honestly just depends on the application and like what kind of loads does it need to be able to withstand and stuff. So like the kind of applications you use ceramic matrix composites are in high temperature. So the oxide composites that CMCs we're working with can withstand up to 1200 degrees C. I don't know how much that is in Fahrenheit, but it's a lot. And so where do you want materials to withstand high temperatures? Rockets, heat shields for things like the space shuttle, the engines used for the planes you're going to see Abuelita in Miami, tomorrow, and in your brakes for your cars. In that area where the rotors are, where your tires are, there's a lot of heat coming through. And so you want your brakes to withstand high temperatures. That's why most of them are ceramic brakes or some form of ceramic carbon fiber brake that can withstand those high temperatures. So that's in general the material and what kind of applications we're doing that are being used. This material is not anything new. It's the same thing with 3D printing. 3D printing was discovered in the 80s. This material was discovered around maybe a little bit before that time, but because of cost and people were like, what are we going to use this for? They kind of just stopped it in its path, and then it never got to see the light of day up until recently, where, as I mentioned before, composites are used for lightweighting. And if you find a material that can be produced in large masses and is also be able to use for lightweighting and for, has really great strength properties and what you're looking for, then let's go for it. And then by having more research and development in the area, you reduce the costs. Carbon fiber, when it first came out, was an arm and a leg. Now, I have it somewhere here, but now carbon fiber is about $25 a pound. And you can see here, it's kind of, it's woven in a different way. So it's $25 a pound, and glass fiber is $1 per pound. When it first was discovered, I'm sure it was like 10 times that price. So that's the importance of going into something and developing the research and development, actually putting money to make it better.
And it goes into everyday things, right? Like carbon fiber, there's like frames for bikes or like things like that, like sports equipment, like all kinds of things. So it's so who knows? Maybe who knows? Like what kind of applications?
Yeah, so like the project that I'll be focusing on predominantly for my PhD is, looking, this material is actually very much monopolized in the industry. The fibers are made by 3M, and the overall slurry is made by another company. So there's very few people in the market that make this material, but there's also unknown relationships about this material. For instance, like in the processing manuals, they don't know why they put certain temperatures for a certain amount of time. They just kind of put it there because it worked. They don't know how the particles size, the distribution of the nanoparticles amongst the fibers, how that's being formed. Can we control it? Why is there that much void content? How much void content do we want? Among other things. Why are these things
is there
all
a
happening?
process? Is there a process that we can put in place that we can standardize, that we can optimize?
Yeah, exactly.
Who knows? Maybe you'll come up with your process. It'll be that. Oh yeah. We just gotta do a Vargas process on this material, and then we can get it out the door.
The Emiliana process.
Yeah, ¿por qué no? ¿Por qué no? That'd be amazing.
Exactly. So there's a lot of unknown relationships. The current process, it's just absolutely expensive. That's why you don't hear too much about them. And if they're used in application, you want to reduce those costs. It's very limited efficiency. And as I mentioned before, there's a pause in development because people aren't willing to risk funding or investing into the R&D. So these are areas that we're going to try to prove the best relationships, how to decrease the costs, how to make it more efficient, and areas that can be looked into further for development into making this material much more common in these kinds of applications.
It's amazing. No, thank you for sharing that. Thank you
hopefully,
for sharing
hopefully
with us.
Yeah, hopefully that abuelita can understand in the Thanksgiving table that. I know it's a lot, so.
No, but what I find beautiful about this is that, and again, I'm just speculating here that maybe like 40 years from now, you'll be the abuelita talking about CMC and composites at the Thanksgiving thing.
Oh my gosh, it's bad enough that I start talking. I brought my parents to the lab and gave them a tour, and they understood everything. I was so happy because it's really hard. This is a lot of advanced stuff that I don't even understand sometimes, and I'll have to Google the answer because somebody will ask me a question. I'm like, let me get back to you.
Yeah. Let me do a lit review. Like, oh my gosh, I totally picture your dad looking around the ovens. So I'm like, mija, but we can put 3 on top of this one and we can make more.
¿Por qué no está haciendo esto? And like, I was like, well, we've never thought about that.
Oye, le corremos una trifásica and we can connect 4 of them in parallel. And sí.
Yeah, exactly. So, so being able to explain all this stuff, like I can even show here, we actually water jet cut a drone body from a carbon fiber composite that we made here. And what's kind of cool is I actually have, let me see if I can just show this. Composites are used in the aerospace industry. This is
Are you carrying a wing? Cuidado, mujer.
Yeah, it's a piece of a Southwest airline part that they give us for demonstrations that we give to people that want training in composites. And maybe you can see it. It's really lightweight. It's not that heavy.
Gotcha.
You can kind of maybe see here, there's like a kind of pattern here. That's there's composites in here, and that's why it's so lightweight. Like literally, I could hold it with one hand.
That's awesome.
And so, composites are used in a lot of places, and they're not. It's not new technology. And one other thing is that in order to increase the stiffness of a composite without adding more layers, is they embed. It's called a sandwich structure. And as you could kind of think of an Oreo, there's something in the middle, and then there's 2 things on the top and the bottom. It uses a honeycomb structure. So you guys have probably seen honeycombs from bees. A lot of things in research are inspired by nature. This is actually paper that is covered with a coating. And this is put in the middle of carbon fiber sheets or whatever composite sheets to not only increase the strength, but also it provides different properties to the whatever the application may be without adding weights. This is extremely lightweight, and it overall just increases the strength. And it doesn't have to be just paper too. There's like metal ones, honeycomb structures, and all the sort. There's also different sizes. It doesn't have to be all the same size.
That's
So,
amazing. That's
so yeah.
amazing. Nice.
So that's a
Thank you
little
so
bit
much for the lab
what I
tour.
do.
That's
Yeah.
awesome.
Yeah. It's like,
No,
now get out.
no,
The
no,
MTV
no, no.
cribs.
I feel like I just got like an intro class to material science. I love it. Thank you so much.
Yeah.
Thank
It's
you so
like a
much.
condensed in an hour and 20 minutes roughly. Yeah.
Yeah, yeah. So, like, anything else you'd like to add to the folks on the line
Um,
and folks that are going to listen to the podcast?
Well, I can say that besides ceramic matrix composites, I'm also working on additive manufacturing. That would be an entirely different,
Yeah. So, additive
influence.
manufacturing, in layman's terms, 3D printing, right?
Yeah, 3D printing. For those who don't know what 3D printing is, it's basically adding layers in some form of direction of material. So you could kind of think of when you're making a cake, right? You have one layer of a cake, and you stack it on top of the other and top of the other until you make the full cake. So think of that with there's some form of manufacturing process that's adding the layers on top of one another until it reaches a certain height or what kind of part you're trying to print. So I actually have a really funny example of one. I have this little thing that is to hold my
Oh,
glasses.
nice.
Let me see. Give me 1 second. I could show that it could hold glasses in it.
Yeah, it's one of those Galapagos Island statues.
Yeah.
That's really cool.
So
You printed that in your lab?
this one I actually printed with a different printer. This is printed with a stereolithography printer, which is basically using photopolymer resin. What that means, basically, it's a liquid resin that reacts with light. So you could think of when you take photos, it basically is a reaction with light. Film cameras, there's a reaction with light that exposes onto the film, and then it creates there's a chemical reaction that produces the image. So this type of resin is it reacts with the light and hardens into like the layers that you're looking for. And so what we're doing in my lab is we're using fused deposition modeling, or like the filament spool printer that has a nozzle and then it extrudes like a hot glue gun. I basically describe the 3D printer. It's basically a hot glue gun. We've been doing 3D printing for
Hot
so
glue
long.
gun. Oh my
Yeah,
gosh! Like
think about
claro, it makes sense, right? Because
it's 3D
it's deposited
printing.
in layers and layers and layers.
Exactly.
Like, that's
Yeah.
awesome.
Yeah, the hot glue gun is 3D printing. How many times have you decided, oh, let me make like a little cool shape or something with a hot glue gun? That's 3D printing right there.
Yeah, over time.
Printers that are used for printing out your homework assignments and your resume and stuff, that's 3D printing. HP could have been one of the leading innovators in 3D printing had they taken, the opportunity at the time when their printing machinery was developed, but they kind of didn't act upon it, and then somebody came in and kind of took over. As Stratasys, if I remember correctly, was they ended up pulling out patents before HP did, and then game over.
Yeah.
But
yeah. It's
printing.
It's one of those things, right? Like Blockbuster had the chance to buy Netflix for
Exactly.
$50 million, right?
Yeah. Remember when Netflix was in the mail? It was sent in the mail. It's crazy.
And you had to wait for the DVDs to come through.
Exactly.
Yep.
Exactly.
Yeah, the older millennials unite.
But yeah, so we're 3D printing different structures. You can kind of see here, it's like there's valleys and crevices and stuff like that. We're 3D printing structures and then spraying metal nanoparticles on this. So think about a cake. So you have, I love baking. Baking and materials can be just used like any form of explanation. Metallurgy can be used. You could talk about ice cream to talk about phase diagrams, just a little bit of everything. So imagine with a cake, you put the fondant on top, and then the fondant hardens because it's kind of like melted sugar. So when it hardens, imagine you remove the cake. Then all you're left with is the shape of the cake that you had initially. So very similar to this, if you spray metal nanoparticles onto this structure and then remove the polymer, the 3D printed part, you have a part that's made out of metal that's basically the negative of this, which can be used for molds.
Awesome.
What I showed earlier with a composite mold, these are ways to make inexpensive metal molds for things such as you can think about your shoe, like the shoe patterns. You could use molds for that. You could use molds for just about anything that's mass produced. And because this is cost effective and lightweight, you could make multiple designs and iterations of the mold without sacrificing in terms of cost or quality, because they do deteriorate over time. How many press parts you're making, but then you have the ability to churn out multiple ones at a lot faster rate and a lot less expensive. So that's something I'll be working on a little bit in the upcoming future. So stay tuned.
That's awesome. Well, thank you so much, Emily.
Yeah, thank you, everybody.